Hello students, in today's class we will be reading about combination of capacitors. So why do we need to combine the capacitor and how do we combine the capacitor are the two questions which need to be answered in this section. First of all, I will clarify a little and I'll give the detail of the topic and then we will move on to the topic. So, as we have read already, capacitor have capacitance. They are made up of two parallel connected metals. These metallic plates have some area and they are separated by a distance of d. And capacitance is the property of capacitor that is given as C equals to Q upon V. This is the very much important and the basic formula for our upcoming sections where we are going to read the combination. Okay, basic lead to understand capacitor combination. Okay, so here C do not depend upon Q or V, but depends upon size, shape and geometry of capacitor plates. So this is basically basics which we have read again and again in the previous classes. So in these basic, the only thing which is quite important and we need to understand and remember and memorize is this formula C equals to Q upon V. Now we will see how do we combine the capacitor. First thing is how combinations are happening. So we are combining them in a line or parallel to each other. When C1, C2, C3 are combined in a line, they are called series combination. But when these are combined like C1, C2, C3, one upon another like stackings, they are called parallel. In parallel lines they are. Now they are not in a single line but instead are in the combination in the parallel lines. So they are called combination of the parallels, parallel combination. Okay, so how we are combining? We are combining in two ways which we have read. Now the second question which arises, why do we need combination? So the very simple answer for this is that you have got capacitors of 10 microfarad capacitance. Okay, you have got many capacitors, not just one but many. Now someone came to you and asked you, kindly make a capacitor of capacitance 5 microfarad. And then the other person came and he said, no, 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 I want something with 25 microfarad. But what you got is only 10 microfarad. Now what will you do? Now you will try to do something with this 10 microfarad so that you can convert it into 5 or 25 respectively. Okay, whatever value. So when we combine capacitors, we aim at making capacitor of desired capacitance, So because we are making different combinations, that different combination gives us different capacitance value. So if we need a 5 microfarad, we can create. If we need a 25 microfarad, we can create that also by combining many 10 microfarad capacitors. We do not need exactly 5 or 25 or 35 or maybe 90, 100, 2000, 4000. We don't need these many like capacitors. We just need a very small capacitor to make a big also by such combination. Now we will see in which combination what sort of result we are finding. Like as I have defined series combination and parallel combination. So there are only two kind of combination. Either we can make these capacitors in line, like one capacitor over here, and other combination is they are combined like this. So in these two cases, what happens? This is in series and this is in the parallel combination. So only such two cases are available. Other than that, you will see like geometry like this. They will be like this. So here also you have to find which two capacitors are in parallel and which two are in series. Okay. Once you find this thing, you can do further studies. Now we will understand the circuital diagram for the series combined capacitors. Series combination of capacitors. Now we have capacitor. This is the symbol of capacitor, two parallel lines. This capacitor is having a value of capacitance C1, and then we have another capacitor that is having C2. Similarly, we have n number of capacitors with us, and this is Cn. Now when we say these are serially connected, that implies that these are connected like this. So this is series connection, C1, C2, C3 dash 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 upon Cn. Okay. Now we will make a circuital diagram. Before that, the important formula is C equals to QV, because when we will deal with a circuit, here we have to define the charge which is passing through the circuit. Charge passing through circuit, charge is given by Q, and then V, the potential across the given circuit or the circuit under consideration. Potential across the circuit. So here we will make the circuit diagram like this. We will take n number of capacitors in the circuit. This is our switch of circuit. Then this is our battery of circuit. Once the circuit is switched on, there is a flow of current, and this current in turn have charge in it. So charge Q flows. This is a battery which provides potential to the given circuit. Hence, the potential provided to this capacitor comes from this battery, and these are V. Okay. So, I will write name capacitor as C1, C2, C3 dash 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 upon Cn. This is a circuit diagram showing series connection, series combination or connection, anything you feel better to write or easy to remember. So in this series combination we got three things, C, Q and V. Out of this is what we need to calculate according to the combination. Calculate according to the combination. But Q is being provided in the circuit and V is also being provided in the circuit. But out of these two quantities, one quantity will remain constant. Now when we are dealing with a series combination, charge is what will remain constant. Charge remains constant. So the Q will remain constant. Here for this Q, charge Q for C1, for C2 charge Q, for C3 charge Q and for Cn it is charge Q. So for all C1, C2, C3 up to Cn, the charge Q is same. But what about the voltage? For C1 voltage is V1, for C2 it is V2, for C3 V3 and for nth it is Vn. So C1 it is V1. Just a minute, we'll write again. C1 it is V1 voltage, C2 it is V2 voltage, C3 it is V3 voltage, similarly Cn it is Vn voltage. Now we will derive the series combination as per to the upcoming notes. So here what is important is to know a constant and a variable value. For that only I have taken this introductory additional pages. Constant and variable. There are two values. One is constant, another one is variable. The constant value is charge Q and the variable over here is the voltage V. So in these constant and variable values, this concept we are going to use. The other thing which we are going to use is the formula C equals to Q upon V. These are the two things we are going to use to derive a formula which will give us capacitance for the combination, capacitance or the effective capacitance for the given combination of capacitors in series. So let's get started with today's class. So today's class's topic is combination of capacitors. We can combine capacitors of capacitance C1, C2 and Cn to obtain a system with some effective capacitance C. This is our main motive. We want to get some effective capacitance C which is either bigger than C1, C2, C3, C4 or is smaller than C1, C2, C3, C4. So that when we are having only a monotone kind of capacitor, we can create more combinations, we can create more variability in the capacitance storage. So capacitors in series is the first sub part of combination of capacitors. Here as you can see the diagram, this is a capacitor C1. This is another capacitor C2. Both are connected in a single line. See, this is the connection of the line. Now, one plate of the capacitor contains plus Q charge. So as we have read while knowing about capacitor, in similar fashion the other plate is containing a charge of minus Q. Now the capacitor C2 also following the same trend, one plate containing plus Q charge and the other minus Q charge. Similarly, all the plates in a capacitor will be containing a plus Q and a minus Q charge. Now as figure 2, this is the figure 2, see, this is the figure 2 and this one is the figure 1. This figure 1 is just showing the combination in one form. But this figure 2 is showing us a combination in the format of series. See, this is one capacitor, highlighted one yellow, blue. This is another capacitor C2, purple C3, and as we go ahead, this is the nth capacitor. This is the nth capacitor. So these all are connected in a same line, in a same sequence, 1, 2, 3, 4, or the nth, not exactly the fourth but the nth. Okay. So they are connected in a series. Figure 2 shows combination of capacitors in series. The left plate of capacitor C1, see, this one is the left plate, this one is the right plate. Okay, left, right, left, right, left, right, left and right. And the right plate of capacitor C2 are connected to the terminals of battery. Hence charges plus Q and minus Q. What they are saying is that this is C1 and this is C2. This is connected to this battery. This battery's terminal is plus and this is minus. So this side all the charges are minus. This side of C1 is also minus, whereas this side of C1 is plus and this side of C2 is plus. So this is based on the polarity of the battery to which our capacitors are being connected. It then follows as the right plate of C1 has charge minus Q and the left plate of capacitor C2 has a charge of Q. Because of this charge configuration, net charge on the capacitor plate is 0. This is plus Q, this is minus Q, but both are having same magnitude. It is like a system where equal number of positive charge and equal number of negative charge exist. Equal number of positive and negative charge existing. So what is the thing in this case is that net charge, if we try to find net Q in this system, how much will it be? 0. Like, see, you are earning 20,000 a month and your household expenses are also 20,000. How much is the amount you are going to gain? You will be saving 0 money. So this is what happening. The amount of positive charges and negative charges in this system of capacitors is equal, and hence when we see these two plates as one entity, what it comes? It comes to be 0. Net charge turns out to be 0. This would result in an electric field in the conductor connecting C1 and C2. Both these will have some electric field due to the motion of the charges. Okay, electric field, presence of battery Motion of charges 2. Charge would flow until the net charge on both C1 and C2 is 0 and there is no electric field in the conductor connecting C1 and C2. So now there is some electric field that is being generated. So to oppose this generated electric field, the charges will start moving in the opposite direction and they will move unless they actually equalizes the charges on both the capacitor and makes the net charge 0. Why to acquire net charge 0? So that they are attaining some stability and there is no electric field force on the two capacitors. So they have more efficient working in such a condition. Thus in the series combination, charges on the two plate plus or minus Q are same on each capacitor, but the potential change, because we are trying to maintain the same charge on both plates. So electric field effects can be subsided. First thing. Second thing is net charge can be made 0. The total potential drop V across the combination is the sum of potential drops V1 and V2 across the C1 and C2 respectively. Now when Q is constant or equal for both, constant or equal, then V is a variable. For C1 it is V1 and for C2 it is V2. So what is the V combined? We need to find V combined, that is equals to V1 plus V2. So from this particular formula, C equals to Q upon V, we will find V comes around to be Q upon C. So V1 will be V1 equals to Q by C1 and V2 equals to Q upon C2. How come this formula came? We have rewritten our basic formula. The basic formula was C equals to Q upon V. This is the basic formula as I have already explained. So this basic formula is rewritten in the form of V equals to Q upon C. So here Q is same. So for both V1 and V2, Q will remain same and there will be a difference in C1 and C2. Hence we got this equation V1 equals to Q1 by C and V2 equals to Q by C2. Now we know that V combination equals to Q upon C combination, right? If we can write V1 ka value as this and V2 ka value as this, we can write the V combination as this too. So we will now substitute all these V1, V and V2's value in this equation. We will get Q upon C combination equals to Q upon C1 plus Q upon C2. Now Q is same in all the three terms. Q will cancel out. What is the thing which we are left with? We are left with C combination. 1 upon C combination equals to 1 upon C1 plus 1 upon C2. And then the C combination comes to be C1 C2 upon C1 plus C2. This is what we have got the formula for a combination of capacitors in series. Combination of capacitors in series. This is the last formula. I'll just read up my derivation, the note derivation here. See, I have explained this the whole in this way Now it is time for us to understand what is written on it. Okay. V equals to V1 plus V2. V1's value is Q upon C1 and V2's value is Q upon C2. From this equation we have found that V's value is Q upon C, and this value we are not writing as Q upon C because we know that 1 upon C equals to V upon Q. See the recombination I will write over here, C equals to Q upon V. When we want to find voltage we can write Q upon C. When we want to find the charge we can write as CV. And when we want to find 1 upon C it will be V upon Q. And when we want to find 1 upon V it will be C upon Q. Okay, these are the derivations. Now see this equation over here. The fourth one is what we have used here in this step number 2. So V upon Q equals to 1 upon C1 plus 1 upon C2. Now we can regard the combination as an effective capacitor with charge Q and potential difference V. Effective is having a charge of Q and potential of V. So this is our basic formula where we have substituted the charge and the potential difference. Now comparing the equation 2 and 3. See how do we compare this equation number 2 and equation number 3, because this gives us 1 upon the combination capacitor. 1 upon the combination capacitor is given by equation number 2. Now we substituted this here in this comparing equation number 2 and 3. See over here, 1 upon C equals to 1 upon C1 plus 1 upon C2. For n number of capacitor, this is for 2 number of capacitor, 2 capacitors. Now we are having n number of capacitor. We don't know how many number we are having. We can have 2, 3, 4, 5, 10,000, 10,000, anything. Okay. So for any number, we will first of all we will define the potential difference. We will define the potential difference. Here what is defined is the potential difference. Now this potential difference, the value is Q upon C1 plus Q upon C2 and blah 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 till Q upon Cn. Okay. So this Q upon Cn, this whole value is equated with our V combination. V combination is Q upon C combination. The whole Q from here and this equation will cancel out, giving us only 1 upon C combination equals to 1 upon C1 plus C2 plus C3 up to Cn. So this is the equation which is valid for n number of capacitors connected in series. Now we have seen combination when we had only 2 capacitor, and then we try to find the combination when we had n number of capacitor. 2 capacitor, n capacitor. Now within a minute we will derive the whole formula here, so that we have a basic simple knowledge how we did previously. It is like a summary of this concept here, and this summary is important in this section because this is a very important formula one need to remember, and we will solve out few problems related to these formulas also, as it plays a very important role in your board examination as well as in your entrance examination. As this topic is extremely important, in a similar fashion this topic is extremely easy also. It is the most point scoring topic in the these three units, like this combination of capacitors. In the next chapter you will be reading the combination of resistors. These combination questions are extremely easy, straight to the formula, no need to use a lot of your brain capacity here, and you will be easily able to find the given answer. So these are the easiest scoring topics, and equally important also. So if you are writing a board exam or entrance examination, it is 102% sure that you will get definitely a question on the combination of a capacitor or resistance. It is like either or case. You will never get both the things together, but if you are lucky, you can get both of these combinations together also. So just for our understanding, we will go through this equation very fastly. Okay, so we know capacitance equals to charge upon the potential difference. For n number also we know charge upon the potential. Now we have used the two capacitance and we have connected it to battery V or B. Okay, now here in this case we have connected the n number of capacitors. This is C1, C2, C3 and Cn. Okay, now in this case charge will remain constant because these are series connection, charge constant and V variable. Similar over here, Q constant, V variable. So the variable V across this series combination is given as V of combination equals to V1 plus V2. In this case, V of combination equals to V1 plus V2 plus V3 plus dash 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 up to Vn. Okay. Now from this, rearranging this particular formula, this formula and this formula, if we rearrange, we will find V equals to Q upon C. So here V1 can be written as Q upon C1 and V2 can be written as Q upon C2. So the V combination equals to Q upon C1 plus Q upon C2. Now V combination equals to Q upon C combination. We will substitute this equation in the above equation and we will get that Q upon C combination equals to Q upon C1 plus Q upon C2. Here Q are same, will get cancel out and the resultant which we are left with is 1 upon C combination equals to 1 upon C1 plus 1 upon C2. This can be rearranged and written. I will show you after deriving a formula for this case. So see, Vc equals to this, V1 equals to Q upon C1, V2 equals to Q upon C2, V3 equals to Q upon C3 and Vn equals to Q upon Cn. We will substitute these values over here. V combination equals to Q upon C1 plus Q upon C2 plus Q upon C3 dash 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 up to Q upon Cn. Now Vc equals to Q upon C combination. In similar fashion, Q upon C combination equals to Q upon C1 plus Q upon C2 plus Q upon C3 up to Q upon Cn. Now this Q will get cancelled out. All are in numerator and are equal. In numerator as well as are equal. So 1 upon C combination equals to 1 upon C1, 1 upon C2 plus 1 upon C3 up to 1 upon Cn. So this is the combination. Now we have n number of capacitors here which are connected in series and this is the resultant. This is the resultant value. So this one page is quite important for you and make a note of it. Resultant capacitance. Okay, now this one I have told you that can be rearranged because we have got only two capacitor. It is easy to rearrange. So we got equation 1 upon C combination or combine, then that is equals to 1 upon C1 plus C2. So we will see the reciprocated one, that will come C combination equals to C1 C2 upon C1 plus C2. So this is what we have got. Now I will just go with one example here in this right hand corner. see, we have C1 equals to 4 microfarad and C2 equals to 10 microfarad. Okay, now these are connected in series. Find the combination of these two. So what is the formula for this? The formula is C combination equals to C1 C2 upon C1 plus C2. Add these values, like substitute these values as given. 4 into 10 upon 4 plus 10, that is 40 upon 14, it will come 20 upon 7. Okay, so C combination is 20 upon 7 microfarad. This is how you are going to solve any question given when the capacitors are arranged in series. So this one example I gave you so that you have a numerical clarity. So whenever you are solving a numerical, you are able to easily tackle it. So that's all for today's class. In today's class we have read capacitor in the series and derived the formula for the capacitance for a given combination. We have seen the derivation for the combination of two capacitors and when there is n number of capacitor. Here n can stand for any value, n can be 0, 1, 2, 3, 4 up to any value. So mostly we do not consider 0 and 1. When there is no capacitor, there is no need to find capacitance, and for 1 it will remain the same. So n is mostly valid from 2 and it goes up to how many combinations you want to find for. Okay, so that's all for today's class. We'll meet up in the next class with a new topic, or basically the another subtopic of this concept, where we will read about the capacitors in parallel combination. So have a good day. Bye bye.